We are going to look at trig function values for angles that are not acute. So say we have a 135-degree angle. The first thing that you're going to want to do for these is sketch your angle in the coordinate plane. So remember, when you sketch, it's handy to label your quadrant boundaries. So 135 is smack dab in the middle of 90 and 180. Use an arrow to indicate your direction of rotation, so that one was positive. Now, the key to these is something called a reference angle. So your reference angle is formed by the terminal side of your angle and the x-axis. For this one I just drew up here, it's that angle that I highlighted in orange. So between my terminal side and my x-axis, that little theta in the right-hand corner if I draw a triangle there. So that measure is how far it is between 135 and 180 degrees. So it's a 45-degree reference angle. They use like theta with the little prime apostrophe to represent your reference angle. So depending on what quadrant, you might have to do a little bit of different thinking. So like if I'm in quadrant 3, I'm past 180 by 30 degrees for 210. So that's a 30-degree reference angle. If in quadrant 4, you're going to want to think of that as 360 degrees and go, okay, how far is it between 360 and 330? Would be 30 degrees. The key is you're going to the closest x-axis, not the y-axis, not the further away x-axis, straight up perpendicular to your closest x-axis. So let's find some reference angles. If you draw a 294-degree angle, it's going to have its terminal side down in quadrant 4. So a little bit past 270. And now your reference angle is the distance between that terminal side, the angle measure between that terminal side and 360, which if you want to find how far it is between those two, we just subtract 360 minus 294 degrees, and you would end up with 66 degrees for your reference angle. For this one, since it's over 360 degrees, I would go ahead and get a coterminal angle so I can figure out like how many 360 rotations are in there and how far past my full rotation I need to go. So if I subtract 360 a couple times, I get 163 degrees is a coterminal angle. So let's draw my picture. I'll go ahead and do, since I'm sketching my original angle, 2 full rotations and then 163 degrees past that would put me right there. So I've got that angle measure right there is 163 degrees. And now for my reference angle, figuring out the distance angle measure between my terminal side and my x-axis is how far is it between 163 and 180 degrees. Your reference angles are always positive, by the way, so bigger minus smaller would give you 17 degrees. If you have angles that aren't acute and their terminal sides fall in a quadrant besides quadrant 1, then you're going to have some different positive and negative signs on your trig functions. Like in quadrant 1, all of our trig function values have been positive, because if you think about it, in the coordinate plane, if I think of those horizontal distances, x and y, they'd be positive. In quadrant 2, though, if you look, like my adjacent side, if I think of that as my x value, is negative. Only my opposite and hypotenuse would be positive values, so only the trig functions involving those, sine and cosecant, would be positive. Like adjacent over hypotenuse, cosine would be -1 over square root 2. So if you think through each quadrant, like in quadrant 3, well, I don't have 2 positive sides, but I have 2 negative. So if I have my opposite and adjacent sides are both negative, because my x and y values would both be negative there, then negative divided by negative gives me positive for tangent and cotangent, but any other trig function values are going to be negative. And then in quadrant 4, now I have 2 positive sides, my adjacent side and my hypotenuse. That means cosine and secant, its reciprocal, would be positive, but all of my other trig function values are going to be negative, because that's the only way I can divide 2 sides and get a positive value. So if you draw your triangle in the coordinate plane and like label its sides, then you won't really screw it up. So I would highly recommend that when you are doing any trig function values for non-acute angles that you go ahead and, like I did here, draw your angles in the coordinate plane and then think, well, should this side be negative because it's going downwards below the x-axis or to the left of your y-axis? So when you're finding trig function values, like I said, for those non-acute angles, make sure you remember to check your positive and negative signs. Let's do this one. If you draw it, you can't really go wrong. So 135 degrees would be, if I label my boundaries here, 90, 180, it'd be right in the middle of 90 and 180 degrees for my terminal side. Now if I draw a triangle down, make that side perpendicular to my x-axis, then my reference angle right there is the angle measure what I get when I subtract 180 and 135 degrees. So my reference angle is 45 degrees. Let's make this bigger. Okay, and also, since I sized it up, my lines are kind of thick, so pause. There we go. So we've got a 45 degree, 90 degree special triangle. So if you label your sides, that one, the vertical would be positive. You're going like left, so your x value would be negative. So your side lengths should look like that with the positives and negatives. And then if I just use what I already know about my trig function values, jotting them down's half the work. Make sure that you put like sine of 135 and not sine of like 45 degrees because we are doing a 135 degree angle. It's just we're using a 45 degree reference angle. So label everything, and then do sine is opposite over hypotenuse, so that'd be positive 1 over square root 2, and rationalize as always, so square root 2 over 2. Cosine, your adjacent side, is negative 1 over your hypotenuse, square root 2, and so on and so forth. You might be thinking, like, well, why did Miss McNabb just have me label a side length as a negative number? It's because the trig functions are actually defined by dividing coordinates of points on the terminal side. It's just that these definitions that you're more familiar with relate to side lengths of right triangles. We'll do the point definitions later.